Hi everyone. In the last video, we covered a data structure, singly linked list, and we covered various helper operations that we could implement on a singly linked list. And that gave us a pretty much idea of how a linked list could be constructed, what are the helper functions we could construct, how to construct. Today we would be looking into a different data structure. It's called a doubly linked list. So most of the things that we learned in a single linked list would remain the same. A doubly linked list gives uh, a better searching over a singly linked list. So let's see how we can implement a doubly linked list, and then we'll write some helper operations like toString, push and pop of a doubly linked list today. So enough of talking, let's code with JS. Yeah. So what is a doubly linked list first of all? So doubly linked list is moreover what a singly linked list is. Like first of all, when our head is pointing to a null, everything remains same. When our head is pointing to a first node, it remains the same. But when we get a second node after the first node, then things change a little bit. So the second node is still the next of the second node is still pointing to null, but there is a previous now. So the previous of the second node is pointing to the first node. That is the only thing that changes in a doubly linked list. And any subsequent nodes, like for example third node, would also be pointing to the previous node. Okay, so third node would be pointing to second node would be pointing to first node. So this way, unlike a singly linked list where you cannot traverse backwards, in a doubly linked list you can also traverse backwards. Having said that, so now our node would have three values. Okay, a value, a previous pointer and a next pointer. Okay, that is what would change in our node. The head would remain the same, exactly the same, it would just have a next node, and that is what would change on our node. Okay, simple, right? And let's also discuss like how we would do push and pop. So in order to push, okay, so if our node is empty, okay, our linked list is empty, doubly linked list, and we need to add just a first node. So the way we did the push on our singly linked list, it would remain exactly the same. But for any subsequent pushes after there is one node already present on our doubly linked list, we would also have to point back. Okay, so these new nodes would also be pointing back. Okay, and since our node data structure consists of a previous node, so like for the first node the previous points to null because we don't have a previous node. Okay, so just to keep things consistent, it points to null, and the next here points to null. Okay, over here the first node, the previous points to null, the next points to second node. For the second node, previous points to first node, next points to null. Okay, and and over here for the second node, previous points to first node and next points to third node. Okay, that's how push would be made. For pop, it's simple. We would have to iterate over to the last value, okay, which is just before the null, and just remove that. Okay, so like if I want to remove this second node, then I would go to the first node and point its next to null, and this would be removed. If I want to remove the third node from here, I would go to the second node and its next would point to null. Okay, so most of the knowledge that we have gained from our previous data structure, singly linked list, it would remain the same. Okay, so let's go forward and write those operations. Okay, so I have already kept the same code over here. So our head has a next, our node has one new property previous, and our doubly linked list has a head and a toString method which we would use to console things out. Okay, so now let's go and write the push function. Okay, so if we want to push, we would use the similar concept which we have already learned, that this dot head dot next, if it is null, then this dot head dot next I would assign as new node, and node now takes a value, so let's pass the value, and the second parameter takes next, so the next would be null because this is the case where I'm adding a first node only, and the previous would also be null in this case. Okay, and if this is the case, let's just return. If it is not the case, we would make a current node which would be this dot head dot next, and we would also need to make a last node, because why we need a last node, because we want to give the value of the previous. Okay, now once we add any subsequent node, so that's why we also need a pointer or the value of the last node, and this could be same as current node while current node dot next not local storage, uh, last node is equals to current node is equals to current node dot next, and then current node dot next we would assign the new node value. Next would obviously be null because it would be pointing to the next node, and previous node would be last node, that's why we made the last node. Okay, yes, so that should be our push. Let's test it out. Okay, so for testing it out, let's add a value to our push. Okay, and let's log out console.log my list dot toString my list dot push 0, and then again log it out. Yeah, let's test. Okay, so head next null. Yeah, so our previous is pointing to null and next is also pointing to null. Okay, let's add another value and again log it out. Oh, and we got an error. So converting circular structure to JSON starting with object node, property next, object with constructor. Okay, I understood. So what is happening? our JSON.stringify is not able to print it out. Why? Because now we have a circular object. Why we have a circular object? Because so our push worked perfectly fine. So in memory, what is happening? First node is pointing to second node, okay, and second node is again pointing to first node. So over here we have a circular structure, and that's why this JSON.stringify, which we are using to log it out, is giving us a error. Okay, so what to do? I think we would have to then change our way of logging, and we would have to find a different way of printing our doubly linked list to the console. Okay, I have a idea how to do that. This dot head dot next, if we would be like iterating over and adding the values, we would be reading the values of each node and printing them to the console one by one. That's what we would do, and that way we would not have any problems with like the problem we were getting. So this is the case when our linked list is null. So let's just print in that case null. Okay, and if it is not null, then we need to print it out one by one. So let me make a small function check type over here, which will take two arguments, node and string, and if node is null, then it should return null, otherwise return what was passed. Okay, yeah, okay, yeah. So why I have made this inner function in this function? Because I would be passing the nodes, like for example previous node or the next node, okay, and obviously we would not be printing the whatever is there on the next or whatever is there on the previous, okay, because again that would lead us to that circular structure problem which we are getting. So we would just print like uh, like this, previous, or some value of our node, and next, and this would be either next or it could be null, and same our previous could be previous or null. So if it would have a previous value or it would have a next value, it means it is pointing to the previous node or the next node, and if it is null, I would just be printing null. So that's what I'm trying to do. So I'm checking if node is null, return null, otherwise return string, and I would, in the string I would pass previous or prev or next. Yes, and then let previous is equals to check type current node which we created. So current node dot previous and previous. Okay, so I will get a value of the previous for it. So for the first time when I would try to find the value of previous, current node dot previous is head dot next, right? So the first time it would try to do this, when it would have obviously a first node, otherwise it would go inside and just print this. The previous of the first node would be null. So current node dot previous would be null, and I'm passing the value previous, so it would return null, and that's why null would be printed. Yeah. And similarly we would do for next, and yes, it would also be next, and let's call it displayable list that we want to display. Let's call it display list, and it would be like obviously the first node, so whatever this is. Okay, and over here it would be the first node, so I'm using this. This gives you a better way of just, if you want to uh, add some dynamic values to a string, it's the newer way with EH6 that is given to you. And this, and the value current node dot value, and next. Yes, so this would print my list, and I would just return it back. Yes, of course I would have to still iterate over, but let's test whether this is working or not for our two elements in the list. And okay, so yes, next null when our list was empty, correct, when we had a zeroth value. So this, so for previous it's null, for next is null, right? And okay, this is not printed correctly because we have not iterated yet. So for iterating we would use the similar logic. If current node dot next, current node is equals to current node dot next, and we would like construct our previous and next. Okay, from the current node, and we would construct our display list also similarly. And over here, instead of, I would have to do some changes. Okay, this is fine. Okay, it would print the current node, but I need to add over here our display list. Yes, and then it would be appended one by one. Let me test it out. Okay, so next, previous is null, next is there for 1, next is null, and previous is also present. So far so good. So just to reiterate, I have what I've done over here, I have iterated over, okay, and I am making this structure over here, okay, and I'm using this check type function to return either null or previous or next, whatever I have passed based on what the value is, and I am appending it every time to the already existing value. Okay, just string manipulation I'm doing, and I'm just returning it. So that way I am able to log this doubly linked list to the console. Let's test it out for some more values. Okay, I have a next, zeros next, 1 next, 2 next, and 3 next is null. Okay, 3 has a previous which is pointing to the second, 2 has a previous which is pointing to 1, 1 has a previous which is pointing to 0, and 0 doesn't have a previous because it's pointing to the first node. Great. So our push is working, our new stringify function is working, which I think is, it gives a better result than our json.stringify. It looks more readable now. So what's left for today? Let's write the pop. So pop would remain the same, most of it would remain probably the same. Yes. I missed this. Okay, so for popping the values out, we'll follow the similar approach. If this dot head dot next is this, our list is empty, then we would throw an error just like last time. By the way, if you have not watched the last video, I would recommend you to go and watch that, and then this implementation would become really simple to understand. Current node is equals to this dot head, and we would also maintain a last node which is current node, because while popping out we want an instance of the last node. And yes, we would obviously be iterating over current node dot next. Last node would become current node, current node would be current node dot next, because we would make a variable to store the value, because we need to return it. We will do last node dot next is equals to null, and return this value, and it should work. Console.log my list dot pop. Let's test it out. Yes, it printed 3 for us, and I forgot to also print this. So perfect. 2, the value for the next of 2 is pointing to null, and this node has been removed. Great. Let's test it. Till here. Yeah, so we have popped everything from our linked list, and now our linked list is again null. If we would do pop again this, we would throw this error that list is empty. So that's the implementation of a doubly linked list. Okay, so a doubly linked list consumes more memory because for every node we are also adding a pointer to the previous node. Okay, so it's, it takes more memory, but the advantage it gives us over a singly linked list is that we can also traverse backwards in any case. Okay, so another you know advantage it gives us is that if you know which node you are on. Okay, suppose I'm already on the second node and someone asks me to delete it. We okay so for deletion we always need the reference to the node prior to the existing node. Okay, so in that case for a single linked list I would still have to iterate over till this node and you know uh, have a pointer for the last node just like we maintain this last node, and then I would be able to delete. But over here if you know you know you are on any node, then you can easily delete it because just by doing the previous for that node would give you the value for the first node. So only in this scenario the deletion on a doubly linked list is of constant time as compared to the deletion on a single linked list, which is like linear time. Okay, yeah, that's for today. uh, if you have not subscribed, do subscribe, as I would be making more videos on such data structures and their implementations. Please like the video, and next time we would you know try to understand a new data structure. Next time we would try to understand stack, and then we would see how we can implement an stack data structure in memory. So that's for today. Thank you.